Hello friends, welcome to our channel. In this video, we are going to look at today's daily challenge problem 2429, minimize exclusive OR. This is actually a very easy problem, but our purpose or motivation is to share with you the thought process. So basically here we have two numbers and we want find another number. So this number x has the same number of set bit as one of the numbers and try to minimize the other number. That's the main statement. So here I would like to quickly look at the two examples. Let me see. Yeah. So here in example 1, so we have number 1 is 3 and number 2 is 5. So if we look at the binary representation of 5, so it's actually 1 or 1, right? So there are two set bits. So two set bits. So in other words, our x will have two set bits, but we want to try to make this number with respect to x has a very small exclusive OR. So the binary representation of this one is nothing but 1, 1. So because we have one set bit, so we can set x like this. We can first make the leading position here to be 0. So we put a 1 here, and then we put another one in to cancel this one. So we are going to have 1, 1 in binary. So that is 3. So this is the example 1. So now if you look at example 2, so we have 1 and 12. So if you look at the binary representation of 12, so that is 8 plus 4, right? So this is 8 plus 4, this is the 1. So then there are two set bits, right? So then the binary representation of 1 is nothing but 1, right? So in the first bit, I just want to cancel this one, right? And then we have another bit, but we can only add in front, right? So again, we have 3. So I guess still in a sense, these two examples are not very representative. So let's look at another one. Let's have 8 and 10, see. So 10, actually it has 1, this is 8, this is 8, right? Plus 2. So that's 10. But if you look at 8, so it's 1 and 0, 0, 0, right? So then, because we have two set bits, so first I need to cancel this one. So we put it here, right? And then we have another set bit, so we need to put it to the very end, right? So in between, we put two zeros, right? So this way, you are going to get, so this is actually 10 minus 1, that is none, right? So overall, the strategy will be the following. Strategy, try to cancel out the ones in nums 1 from left to right, right? Because left positions corresponds to more significant ones, right? So here are the ones we mean in binary representation. So with that said, I guess we are ready to look at the code. So here actually we can write very short code, but that's not our purpose. So I want to share with you the thought process. First, we can get the binary representations of these two numbers. So in 1 and 2, so we use this function. You can write your own function, right? So from 2, right? So num2 also from 2, because the first two is 0b. So notice that this n1 and n2 are two strings consisting of 0 and 1s. So also I want them to be similar. In other words, I want to pass some zeros to the left. So here I can have a length, that is length n1. So if length is less than length n2, right? So then I'm going to set length to be length n2. So in other words, the length after these 3 lines will be the longer between n1 and n2. Or if you like, you can do something like this. Length is the max of length n1 and length n2, right? The same thing. So now what we want to do, I want to pad them, right? So I want to set n1 to be 0 times the length minus length n1, then plus n1. So similarly, I do this for n2. Actually, one of them must have no operations, right? So because the longer will be one of n1 and n2. So this will make sure n1 and n2 have the same length. So now let's count the set bit, count number of set bits in n2, right? So this actually I can even do this set bits. So can do a length. So let's see 1 for y in say n2 if y equals 1, right? So this is the number of set bits I would say, and then we can initialize the result. So the result will have it's a binary representation of a number. Then I'm going to convert it to a decimal number. That's actually very straightforward. First, we want to do what we want to do. We want to cancel out from left to right the set bits in n1, right? Cancel as many as possible, right? So basically we iy in enumerate n1, right? So if y equals 1, so this is the leading 0, right? So then if set bits, so it's greater than 0, right? So we need to set result I to be 1. And then because we used 1, so we need to decrement this by 1. Otherwise, if set bits is already 0, right, we need just break because we cannot cancel out further ones. So this is the 1. And then it's possible that after we do this, we still have ones that are not filled, because which means that after we cancel out all the ones in n1, we still have remaining ones. So then we for this case, we are going to put ones into result from right to left. The reason is the right position actually is less significant, right? So what do we do for I in range? So length minus 1, negative 1, negative 1, right? So then we check if result I is 0. In other words, haven't set yet, and set bit still greater than 0. And then we are going to set result I to be 1 and set bit to be decremented by 1, right? So actually, if this equals 0, actually it's just a run do nothing, right? You can do early stop, but let's put it in the current format. And then that's it actually. So now what we want to do is to return the decimal number represented by this result list. So this is a very simple exercise, right? Simple exercise. So translate result as this is a binary representation and to a decimal number. So basically, let's say our result will be 0, and then we iterate for I in range length. What we want to do is R increments by from right to left, right? So a result, so the length minus 1, so minus I, right? So if I equals 0, so this will be length minus 1. That is the rightmost digit, right? And then we are going to multiply this. So this number is either 0 or 1, right? Then multiply by a power, that is I, right? So then we just need to return this result, right? So this actually forms a complete solution to this problem. So if you look at the code, we write the code in a long format. And that's it to suit our purpose, that is, share the thought process. Now let's look at the test. So in is not defined. Let me see where result in, right? So we need to change this to be a length, right? So now let's run it. So here output expected 5. Let me see where is the problem. So here for y enumerate in 1. So if y equals 1 and this, so we should set this one with decrement, then break, and so let's see n1 n2. So yeah, I guess it's right. So here 1 for y in n2 if y equals 1, right? So we get this one, and then for if result equals 0 and set bit, so we set result I to be 1, and then yeah. So then let's see for I in range length. So we need to return R, not result. Yeah, it passes the 2 cases. Now let's look at generic case. Yeah, it passes all the cases very fast. So also you can so you can try to implement this function by yourself. That's also a good exercise. So here I would say we just provide a format of solution. So this as for coding, you can write a very short code for this problem. I guess with that said, that's about it for the current video. Thank you for watching.